Assalamualaikum and hi, I'm from KA05. Today, my group members and I will present to you our final year project. Now, let me introduce you the presenter. First, I'm Nori Shakirin, the leader of the group. The second one is Muhammad Faizul Hafiz and the third one is Muhammad Nifail. This is our supervisor, Puan Siti Norain binti Muhammad Razali.
So this is a table of content that we will present to you. The first one is chapter 1 introduction, chapter 2 literature review, and then chapter 3 methodology.
Welcome to our presentation to our panel. So today we are going to present about our final year project 1 that is sustainable stabilization of clay soil using coconut coir and starch additive. So this is the first part, which is introduction. So clay soil is frequently used in construction projects due to its extensive availability. But there is a challenges of clay soil, which is high plasticity, low shear strength, and significant volume change due to moisture. Without stabilizer, this type of soil is not suitable for many structure applications. Traditional stabilizers such as lime and cement has been used for a decade and also very effective. But this stabilizer produce high carbon emissions and resource depletion. So there are two problem statements of this study. First, clay soil shrink well behavior cause foundation instability, cracks, and uneven settlement in construction. Second one is traditional stabilizer like cement and lime are unsustainable due to high energy use, carbon emissions, and reliance on non-renewable resources. And then this is the objective of study, which is to determine the optimal mix ratio of starch for clay soil stabilization. Second, to evaluate the strength behavior of original and stabilized clay with added starch and coconut coir. Last but not least, to identify the shrinkage properties of the original and stabilized sample. Now we go through the scope of study. This study examines starch and coconut coir respond as stabilizer agent on clay soil. The sample that will be used will be collected from a farm located in Negeri Sembilan. Moreover, this study intends to figure out the benefits to environment and economy of using natural stabilizer. Instead of that, the study hopes to encourage potential to reduce carbon footprint of construction projects and promote sustainability for use in housing and infrastructure development. Moreover, this study intends to figure out the benefits to environment and economy of using natural stabilizer. Instead of that, the study hopes to encourage potential to reduce carbon footprint of construction projects and promote sustainability for use in housing and infrastructure. For practical implication, this study will contribute to advancing sustainability construction practice by integrating traditional material with modern engineering methods.
Okay, now I'm take over about significance of study. Firstly, eco-friendly solution. Reduce carbon emission. Second, improve soil properties. Enhance clay strength, durability, and moisture resistance. Third, economic and social impact. Provide a low-cost, sustainable stabilization method supporting local economic and waste valorization. Okay, now we move to expected result. Improve soil characteristic. Significant improvement in unconfined compressive strength, that is UCS, due to the cohesive property of starch and the reinforcing effect of coconut coir. Second, optimal stabilizer ratio. Identification of the best ratio of starch to coconut coir for maximizing strength, cohesion, and durability.
Next, for the expected result, practical application, confirmation that starch and coconut coir can effectively stabilize clay soil for real-world construction, especially in areas with problematic clay soil. Next is a long-term impact. Support for green building practice and sustainable infrastructure developed promoting environmentally friendly and durable construction. Now we're moving to chapter 2, literature review.
Now we go through to the chapter 2. first thing first, we have clay formation. Clay formation begin with the weathering of larger rock like granite or basalt, which break down into smaller particles through physical or chemical process. After that, over time pressure and compaction cause these particles to bond, forming and sedimentary rock like shale. Last but not least, this process also contribute to fertile soil essential for agriculture and clay versatility in industry like ceramic and construction. Okay, next, clay behavior. Clay soil present challenge in agriculture and road construction due to its plasticity, compressibility and poor drainage. This affect road and farmland, as clay can shift under pressure leading to uneven surface to waterlogging. In colder climates, frost heave further damage the ground. Proper moisture control and foundation strengthening can also help maintain stability for both road and crop.
Traditional soil stabilizers such as lime, cement, bitumen have been used for a long time in civil engineering. This stabilizer is indeed to enhance soil properties such as increased strength, durability, compressibility, and water resistance. Next is non-traditional stabilizer. For this stabilizer is also include alternatives like cement and bitumen, but they consist of industrial byproducts, natural additives, synthetic chemical, and new technologies that offering environmental and economic benefit. Coconut coir is used as stabilizer in agriculture and construction. It has high strength, durability, moisture retention, and aeration capabilities. It's also environmentally friendly, biodegradable, and a sustainable byproduct of coconut harvesting. Coconut coir considered more environmentally friendly compared to industrial stabilizers. Next, cassava starch is biodegradable, renewable, and eco-friendly to synthetic material. But there are some issues of starch, which is poor mechanical strength and high moisture sensitivity. For improvement of cassava starch, starch can be modified or combined with other materials such as boric acid or glucose to improve its mechanical properties and moisture resistance that will be enabling its use sustainable high performance products.
Next is shrinkage limit test. The shrinkage limit test is a crucial in geotechnical engineering to assess the shrinkage behavior of clay soil, which are prone to significant volume change with moisture fluctuation. The shrinkage limit test represents the moisture content at which soil volume no longer decreases despite future evaporation, indicating stability. This test is vital for understanding clay behavior in drying conditions, as high shrinkage can lead to cracking or instability, especially in areas with seasonal moisture change. Expensive clay, if unmanaged, can cause structure damage. The test helps engineers predict soil movement, guide treatment method, and ensure stability in construction and agriculture by managing moisture content effectively. Now we're moving to the last part of chapter 2. Unconfined compression strength. Unconfined compressive strength is a key measure in geotechnical engineering that assesses the ability of a soil or rock sample to withstand axial compressive stress without lateral support. It is, part, it is particularly useful for testing cohesive soil, like clay, to determine their sustainability for construction, load-bearing capacity, and behavior under stress. The UCS test involves compressing a cylindrical sample to measure the maximum stress before failure and is commonly used for slope stability, embankment, foundation, and pavement design. UCS is expressed in pressure unit like kPa or psi, and is simple and inexpensive to perform. While UCS provide value strength data, it is most effective when combined with other material properties for a comprehensive analysis. The test also reveal failure patterns linked to soil consistency, moisture, and structure. Now we're moving to the last chapter of this presentation. Chapter 3, Methodology.
Okay. Now in the chapter 3 methodology, we have flowchart. First of all, collection of material. After collection of material, we go through soil sampling. After that, sample preparation. Sample preparation, we have three. First, clay. Second, starch. Third, coconut coir. After that, after sample preparation, we go through proctor test. In proctor test, we do original first, and after original, we do stabilize with starch. After original and stabilize with starch, we go through sample formation. After that, we do a unconfined compression test. Uh, After unconfined compression test, we go to shrinkage test. After that, result and discussion. After result and discussion, we go to conclusion and recommendation.
Collection of material. First material is clay. A clay soil sample was taken from a farm in Negeri Sembilan, Malaysia. To guarantee its representativeness, the distributed sample was taken using conventional soil sampling method. Laboratory tests like grain size distribution, Attenborough limits, and moisture content tests will be conducted. Next is starch. Cassava starch, sourced from the cassava plant, is a cost-effective and sustainable material widely used in construction. It improves the durability and strength of material like soil, mortar, and concrete by enhancing dilatation, adhesion, and water retention. What more accessible and affordable than potato starch, cassava starch is biodegradable and support green building practice, making it ideal for surface coating, crack, and soil stabilization. Next is coconut coir. Coconut coir is a natural fiber extracted from the outer husk of coconut. After harvesting and removing the husk, the core is sun-dried to remove moisture, preventing mold and decay. The dried fiber are cut into small pieces for easier processing. Core is used in construction and composite due to its high tensile strength, moisture resistance, and durability. It enhances the stability and environmental resilience of material like reinforced concrete, erosion control mats, and geotextile. So this is the laboratory test that we will conduct. The first one, unconfined compression test. This test is used to determine the compressive strength and shear strength of cohesive soil. It evaluates the soil capacity to withstand axial compression without lateral confinement. Next is particularly useful for assessing soil stability and load-bearing capabilities. Next is proctor test. The proctor test help determine the moisture content at which the soil achieve maximum density. This information is critical for preparing uniform and representative sample for the UCT.
That's all from us. Thank you.